Okay, so today we are performing experiment 11, which is gravimetric analysis. In today's experiments, we are going to be looking at the reaction of calcium chloride and potassium carbonate to make a precipitate of calcium carbonate, which is principal component of chalk. So first and foremost, in order to ensure we are completely ready to go, whoops, one moment. There we go. In order to ensure we are completely ready to go, we are going to prepare our balance. We have all of the other materials for our experiments set aside and ready to go. Now, what we are going to do first and foremost is we are going to weigh out about 2 grams of calcium chloride into a weigh boat. Okay? We're going to leave this sample aside just as a reference. So we're going to get out a weigh boat and we're going to weigh out 2 grams of calcium chloride. So here's our weigh boat. I'm going to put it on the scale and we're going to zero our scale. So as you can see very clearly, it's reading 0, 0. Now we're going to take our calcium chloride provided in our lab box. So here's our calcium chloride, and we're going to weigh out and transfer 2 grams into our weigh boat. Make sure not to spill it. And I like to do my transfers directly above my weigh boat in this case, just to minimize spills. And we're going to set this weigh boat aside. We're going to save it for later, as we're going to use it for a later part of this experiment. So let's continue to weigh out 2 grams of material. And if your balance is acting funny, make sure to calibrate it with deionized water, just like I showed you in the previous laboratory. So let's continue transferring material. We want 2 grams of potassium carbonate. Bags are not very convenient for this, but we'll make do. And let's quickly wipe up any spills really quickly. Okay, so let's continue and finish off weighing out our 2 grams of calcium chloride. Here we go. So as advertised, here's our 2 grams of calcium chloride. And we're going to set this aside for later use in this experiment. Next, what we're going to do is we're going to take a 250 milliliter beaker, a 250 milliliter beaker. We are going to place it on the balance. Oops, there's a little bit of water on the bottom, so let me just clean off that water residue. Okay, so now we're going to place our 250 milliliter beaker on our balance. We're going to tare it, and then we're going to transfer 2 grams. We're going to transfer 2 grams of our solid calcium chloride into this beaker. Now, as this is the last calcium chloride that you're using, if you want, you can try to pour the remaining contents into your beaker, and that should give you approximately 2 grams.
So Professor, for the mass of the calcium chloride in the data table, do we put 4 grams in total?
What was that?
So for the data table on the lab workbook, for
Yep.
calcium chloride in the data table, do we put 4.0 grams for the total?
Could you repeat that, please? One more. Yes, please
For
go
the
ahead.
calcium. So for the lab workbook, there's a data table with all the chemicals we're going to use today. And for calcium chloride, do we put the mass as 4.0 grams or?
No. So the mass of calcium chloride that you're using is the mass of calcium chloride that we weigh out into this beaker here.
So it's going to be 2.0 grams.
Yes, exactly right.
Okay, thank you.
Now, as this balance is not particularly accurate, you may need to really try to get out all the remaining portions of material in your container. So it may take a little bit of shaking and agitating. Bags are not entirely the best method of storing material, but we'll make do with them. So we'll continue to transfer material until our bag is completely empty. or until we have 2 grams. These balances aren't particularly very precise, even when we try to calibrate them and check that they're calibrated. And that's just because they have a relatively low precision.
Hi, Professor.
Yes.
Even though the calcium chloride bag says 4 grams, is it okay if we measured out 2 grams in each one, though? Because there's
Yes.
something left over. Yeah.
Oh, yeah. Sometimes if the balance is not properly fully calibrated, you may end up with, oh, there's 2 grams in this and 2 grams in this. That's perfectly normal. Don't worry too much about that.
Okay.
Mm-hmm. Any other questions I can address? Okay, so let's continue weighing out our calcium chloride. Calcium chloride is pretty hygroscopic. It picks up water somewhat quickly. So you want to try to weigh this as fast as you can within reason. Okay, so after transferring our materials, now what we're going to do is we're going to record the mass of our calcium chloride that we have dispensed. I'm just going to check one thing with a calculator really quickly, just to make sure that if your mass of calcium chloride is undershot, that we won't run into an issue in later parts of this procedure. So we currently have weighed out our calcium chloride, and now we are going to weigh out our potassium carbonate.
Hi, Professor.
Yes.
So in table 1 and table 2, we put 2.0 grams in both calcium chlorides.
Yes, we haven't taken our second calcium chloride reading just yet. We haven't taken our second calcium chloride reading just quite yet.
Okay, okay.
So if
Thank
you
you.
run out, if you're out of calcium chloride, but you don't have the 1.8 grams, you'll just go on with the trial with the material that you have.
Okay.
So let's record the mass of calcium chloride in our beaker. Let's record the mass of calcium chloride in our beaker. So we have 1.8 grams of calcium chloride in our beaker. Okay, so we'll set this beaker off to the side now. So in our next step, we're going to weigh out our potassium carbonate. So to do that, we're going to weigh out and tare a 50 ml beaker. You may need to rinse off and clean off your spatula from the previous weighing step. So make sure to do that if you haven't. You want to minimize cross-contamination, so make sure to clean off and rinse off your spatula. Now that that's taken care of, now that we've cleaned and rinsed off our spatula, we're now going to weigh out 2.5 grams of potassium carbonate. So here's our potassium carbonate. We're going to weigh out 2.5 grams. And potassium carbonate is much less of a pain to weigh out than calcium chloride because potassium carbonate is not as hygroscopic. Here we go. So here's our 2.5 grams of potassium carbonate. So this is the mass of potassium carbonate. Now what we're going to do is we're going to remove our beaker from the scale. We're going to move our scale off to the side. We won't have to use it for a few moments. And now what we're going to do is we're going to use our 100 milliliter graduated cylinder to transfer 25 milliliters of water into the graduated cylinder, and then we're going to stir with our stirring rod. So ultimately what we're going to do is we're going to transfer the contents in our potassium carbonate beaker into our calcium chloride beaker, and we're going to allow the reaction to occur completely. Okay, so let's get started with that procedure. Let's get started with that procedure, and let me move things so we can see them. Let me move things back just a little bit. There we go. Okay, so we're going to take our potassium, oops, zoom in. Okay, so we have our potassium carbonate beaker. We're going to add to it 25 milliliters of distilled deionized water. And in addition, what we're going to do is we're also going to prepare a rinse of about 5 to 10 milliliters of deionized water. Okay. So now what we're going to do is we're going to use our stirring rod, and we're going to mix and dissolve our potassium carbonate. Sorry. So we're going to continue mixing our solution until the entirety or the majority of our potassium carbonate dissolves. We want to transfer all of the potassium carbonate into our beaker. Okay, so now what we're going to do is we're going to rinse off our stirring rod. But we're going to rinse it into the calcium chloride, because ultimately everything's going into the calcium chloride container. Okay, so we'll save this to the side for now. Now what we're going to do is we're going to carefully transfer the contents of our potassium carbonate beaker into our calcium chloride beaker. But before we do that, we're going to dissolve our calcium chloride in 50 milliliters of deionized water. And you want to be really careful with this next step. You want to be really careful with this next step as it will generate heat. It's an exothermic dissolving process. So we have our potassium carbonate all good to go. We have our rinses all good to go. Now what we're going to do is we're going to dissolve our calcium chloride so we can begin. Oops, one moment. Allow me 1 second just to adjust the camera. Okay, so now we're going to dissolve our calcium chloride in 50 milliliters of water very carefully. It may generate some heat. And now we're going to stir the solution to ensure all of our calcium chloride completely dissolves. Okay, so now that we have everything dissolved, what we're going to do is we're going to take our potassium carbonate solution and we're going to directly mix it with our calcium chloride solution. And you may notice immediately upon mixing that a precipitate was generated, that solid was generated. Now, we aren't done quite yet. You're going to also make sure that you rinse your beaker. Make sure any of the droplets get caught back into the container. And now you're going to rinse your potassium carbonate container while stirring your mixture. So let's rinse our potassium carbonate container. Once again, we want to ensure as much of a quantitative transfer as possible. So we're going to use 1 to 2 milliliter aliquots. And we want to ensure that we've transferred all of our potassium carbonate using the minimum amount of water. Okay. So after our repeated rinses, now what we're going to do is we're also going to rinse off our stirring rod with deionized water. Now, in order to ensure that the reaction is fully complete, what we're going to do is we're going to stir this solution under agitation for about 4 minutes. So we'll set our timer, and at about 1:37, we will finish stirring and then allow this solution to sit. Any questions so far? Any questions so far? Is everyone observing about the same results when they're doing this experiment with their own kit? Does everyone get the solid in their beaker? So we'll continue stirring for about another 3 minutes. Any questions so far on this experiment? Any questions so far? Okay, about 2 more minutes of stirring. Okay, so now that we've stirred it for the requisite amount of time, now what we're going to do is we're going to rinse the contents on our stirring rod back into the container by rinsing it with deionized water. And then we are going to allow the sample to sit for 15 minutes. Now, in the meantime, we're going to do some preparation. In the meantime, we're going to do some sample preparation, and we're going to prepare for the next step of this experiment. So what we're going to do is we're going to take our, whoops, sorry about that. One moment. Let me fix the camera one more time. So we're going to leave our sample off to the side, and we'll let it sit for 15 minutes. In the meantime, we're we're going to do some further sample preparation, and we're going to get our filter ready to go. So what we're going to do first and foremost is we're going to take our scale, and we're going to record the mass of a piece of filter paper. In this case, they gave us a pretty monstrous piece for our funnel in your box kit, but we'll record the mass of our filter paper. So let's now zoom in. Oh, sorry about that. The camera's being slightly temperamental today. So let's now zoom in and record the mass of our filter paper. Zoom in on that. Yep, that's okay. You'll just pick one. So here's the mass of our piece of filter paper. Perfect. So we've recorded the mass of our piece of filter paper. Again, one more time, here's our filter paper. Now, what we are going to do is we're going to take our filter paper off of the balance, set it off to the side, and now we're going to take a look at our watch glass. Let's take a look at our watch glass. So for our watch glass, one moment, sorry about that. The camera sometimes has trouble with these adjusting the brightness for these pieces of glassware. Oops, one moment. Here we go. So we're going to take out our watch glass from our laboratory box kit. And we're going to place our watch glass on our balance. And now we're going to record the mass of our watch glass. Just 39.5 grams. Okay. So now that we've recorded the mass of all of our components, what we're going to do is we are going to fold our filter paper such that our funnel and filter paper make a gravity filtration setup. So to accomplish this, let me just move my deionized water to another container. So here's our 250 Erlenmeyer flask. And what we're going to do now that we've taken these masses is we are going to set up a filtration apparatus. And to do that, we're going to place our funnel on top of our Erlenmeyer flask. And now we're going to fold our filter paper. So starting off, when it's open completely, you're going to fold it in half. Okay, so it's open completely, and now you're folding it in half. Now you're going to turn it 90 degrees and fold it in half again. Now you should have something that looks almost like a sandwich. You're going to take the first lip, and you're going to pull the paper out to make almost like a coffee filter. And this is what you're going to be using for gravity filtration. So to show that one more time, you're going to take your filter paper, fold it in half, turn it 90 degrees, fold it in half again. Now you're going to take the first lip, pull it open, and now you have a gravity filtration filter paper. This is going to go into your funnel, which they gave as a little bit oversized in this lab box. And what you're going to do is you're going to use a little bit of deionized water to wet your funnel. So let's showcase that. So you're going to place the funnel and place the filter paper into your funnel. You're going to take a little bit of your deionized water. You're going to pipette it in and slowly allow it to drip on the sides of your funnel. Now, once the filter paper becomes wet, it's very, very fragile. So what you're going to do is you're going to wet it with a little bit of water. If it's working properly, the water should be flowing at a nice slow pace. And then what we're going to do is we're going to take our stirring rod and we're just going to gently, very gently, just push the filter paper on the sides. Just very gentle tapping. We just want to have a nice seal between the filter paper and our funnel. So here's what your final setup should look like if everything has gone well. The filter paper is stuck to the funnel and the liquid passes relatively slowly through your filter funnel. Is everyone okay so far? Is everyone following along so far? Does everyone have their fully prepped filtration setup all set and ready to go? Let me move this back so it's easier to see in the full view. Here we go. We still have our mixture sitting off to the side. It still has a few minutes to go. We have our watch glass that we've weighed already, also sitting off to the side. And now all we're doing is waiting for our reaction to finish. We have about another, so looking at our timer that we set, we had to let it react for 15 minutes. So we have another 10 minutes until we can filter our mixture. So at this time, if there are any questions, I'll address them at this time.
Hi. So it's fine if our filter paper and watch glasses are different grams, like compared to each other?
Yes. Mm-hmm. The watch glass will weigh more than the filter paper. Mm-hmm. So this is a pretty fast experiment outside of waiting for the reaction to complete. We only do one trial. So to answer the question in the chat, yes, we'll be lecturing on the lab calculations after this laboratory run through, and we will be handling we'll be lecturing for a little bit more on chapter 4. Any other questions I can address? Any other questions I can address? let me check your question on table 2. Let me see. I need to double check what table 2 is referencing in this case. So table 2, the calcium chloride is the calcium chloride that we set aside. For table 1, that's the calcium chloride that ended up in our beaker. Does that make sense? Perfect. Let me just check the time really quickly. So it has been a full 22 minutes since we started the reaction and allowed our mixture to sit. So what we're going to do is we're going to take our mixture and let me move the camera so it's a little bit easier to see what's going on. Okay, so we have our solution and we have our precipitate and we have our filter funnel. So what we're going to do is we're going to carefully pour our solution. You want to make sure that the water level doesn't go above your filter funnel. And one trick that you can use to help this along, well, that's more for decanting. So you want to pour relatively quickly after a small amount of agitation. So now let's pour. So it's going to require a little bit of time and patience. Make sure you don't overfill it, and any drops can be rinsed using your deionized water. So we're going to slowly filter the solution and make sure you add some of your solution that you're filtering each time just to ensure the process is efficient. And we'll continue filtering until we've filtered all of our solid onto our filter paper. Note, you should not see any solid in your flask. If you do see solid, that's what your second piece of filter paper is for. Just as a side note, and we'll talk about this in the lab run through, the experiment modification that we made where we use a slightly lower mass of calcium chloride makes the calculations a little bit more interesting in that we have a genuine limiting reactant rather than the quantities being in exact stoichiometric ratios. So we'll be able to calculate that in our lab analysis session. So in the meantime, let's add a little bit more water. You want to keep the water level. You want to keep the solution filtering. You want to keep the water level below the top of the container. And you should not see any white solid or cloudiness in your filtrate liquid. Pardon me, sorry about that. So how's everyone going on the filtration? Is everything going okay?
Yes.
Is the filter paper working as it should?
Yeah.
Perfect, perfect. And you'll slowly notice the solid depositing on your filter paper. So we're still waiting for it to finish filtering, making sure the water level doesn't fall below a certain range, and refilling our filter funnel each time. So let's add a little more liquid after agitation. It's a slow process, but gravity filtration is known for its excellent recovery of material, which will be invaluable in today's experiment. Any questions while we're waiting for the filtration to finish? Remember to keep adding liquid to push forward the filtration process, but don't go over the top of your filter funnel. Everything going okay so far? So we're filtering off our solid precipitate, and then we're using the mass of our solid precipitate to calculate our percent yield by comparing the actual amount of solid that we collect to the theoretical amount of solid expected if our reaction was 100% efficient at completely consuming our limiting reactant to generate product. So we're going to continue to filter this solution. There was a reflection in the bottom of the Erlenmeyer that made me think that there was a bunch of solid, but it's just a reflection from the absorbent pad, thankfully. So we're going to continue filtering our sample, making sure not to go above the making sure not to go above the filter funnel line. Any questions so far? How's everyone doing so far? Everything going okay? So we're just continuing to filter our solution. Now, patience is a virtue for this lab. Patience is a virtue. If anything spills, you're going to want to make sure, or if anything dribbles on the side, you're going to want to make sure to rinse it in with a small amount of deionized water. Just so that way we're capturing the maximum amount of material. As you can see, we're almost done, and we're going to have to do some additional rinses to capture all of this solid. And this is where I'd have my pipette handy, just so that way if any liquid dribbles over, you can catch it. So we're going to rinse this solid rich drop down into our funnel. And now what we're going to do is we're going to successively rinse our beaker with portions of deionized water to capture and transport any leftover solid into our filter paper. So notice how the liquid is relatively rich in solid. Okay, let's continue our rinsing process. And now if you have your spatula handy, you can use your spatula to scrape the solid off the sides and just to get as much of this material as possible. Now, by definition, calcium carbonate is not very soluble in water, so it's a bit of a tricky endeavor. You just want to rinse as much of it as you can and then transfer it into your Erlenmeyer flask. So is everyone almost done filtering? Has everyone almost finished filtering their sample?
I'm finished.
Okay, perfect. While you're waiting for the last portion to finish, what we're going to do is we're going to transfer 5 mils of our isopropyl alcohol into a graduated cylinder, and we'll use that for drying. This is just to expedite the drying process, but we only add it after all of our liquid has all of our water has been filtered and we just have wet solid. So it's a lot of waiting, but once you've completely finished filtering your sample, that is when you'll add the isopropyl alcohol. So just to give everyone a peek, as you can see, that darker white color is our solid precipitate that we've collected. And I'll show you a zoomed in view of our Erlenmeyer flask after it's done filtering. And the beautiful thing about isopropyl alcohol is if you buy it, it's rubbing alcohol, so it's not too dangerous to handle. Though I do mention isopropyl alcohol is flammable, so you don't want to have an open flame anywhere near samples of isopropyl alcohol. It's a bit of a painstaking, it's a bit of a slow process, but it's quite relaxed, all things considered. Not any particular danger of messing up this experiment as long as you don't poke a hole in the filter paper and as long as you record all your masses. And we're just letting our remaining water drip through our filter paper before we add our isopropyl alcohol. So as you can see now, the solid is really starting to become evident. So we can clearly see our solid precipitate that we formed from the reaction of calcium chloride and potassium carbonate. For those following along, is everyone okay? Is their sample almost ready for isopropyl alcohol? If you don't have it, I want you to let the water completely drip through and then let it sit just until I finish adding my isopropyl alcohol and letting it drip through. And then I'll show you how to transfer your filter paper to your watch glass and how I'd want you to store your samples and keep your samples a little bit relatively secure. Any questions on any measurements we're taking? So now that most of our liquid has passed through, I'm now going to add the isopropyl alcohol. And we'll allow our isopropyl alcohol to completely drip through. And then we will finish by transferring our sample to the weigh paper. And unfortunately, we have to wait 24 hours for the sample to fully air dry. And once our sample is air dried, then we'll take some mass measurements. We'll talk about what data is required in this experiment in the lab lecture. We're just waiting for things to filter right now. So if there are any questions at all, don't be shy to ask. Fair amount of waiting, but it will be worth it. Any questions while we're waiting for our filtration to complete? If not, we'll wait until this filtration is complete and then we'll continue our discussion. Any other questions I can address? Don't be shy to ask.
Hi, Professor.
Yes. Mhm.
For the pipettes, are they disposable?
Yes, they are.
Okay.
Mhm. Make sure you rinse them thoroughly with water before you dispose of them, just to be sure.
Okay, thank you.
No problem at all. So it's almost done filtering. Let's just take a look at this. I know for some people it's almost like watching paint dry, waiting for this last little bit of liquid to filter through our funnel. But patience is a virtue. You don't want to get impatient, poke a hole, and have all your solid pass through, only to have to repeat this whole procedure again. So let's let it finish filtering. And once it's done, we're going to be transferring it to our watch glass and allowing it to air dry. So here we've showcased an application of a physical separation of two compounds based on a physical property of solubility. So another application of lecture content. Almost done. This is why we have to let it air dry, because samples take forever to dry, and oven drying filter paper is a bit of a careful process. Okay, so we've gotten off all of our liquid from our sample. Now what we're going to do is we're going to very carefully, very carefully transfer our filter paper, being careful not to tear our filter paper. Very carefully transfer our filter paper And then we're going to place it onto our watch glass. So here's our nice, completely clean filtrate solution. Here is our precipitate on the watch glass. So we have it on our watch glass now. And now what we're going to do is we're going to open up carefully, making sure we're going to open up our filter paper. Here we go. So here's our watch glass with our filter paper completely open. And now what we're going to do is we're going to let this air dry. But what I found is that it's very easy for things to get toppled or bustled. So what I'm going to do is you're going to want to take your other filter paper and just put it as like a little cover on top. And that way it keeps things from falling on it, and it's a little more easily recognizable. So let's move this into a nice, secure area. And then I'm going to put my filter paper on top just to remind me that something is under there, it's air drying, and it's going to take a fair bit of time. So we have our filter paper stored. We'll let it air dry. You're also going to take your calcium chloride, and the way that I like to keep things secure is I like to put another weigh boat on top, and that just keeps it from getting jostled about. So we're going to let these samples air dry for 24 hours, and then we're going to weigh them on our balance. So that's the end of this first part of today's experiment. We're going to continue this experiment tomorrow when we weigh our samples.